Okay, let's talk about it. If you're a parent, you've probably had that moment, staring at your kids' math homework and thinking, what on earth is this? Today, we're going to pull back the curtain on this so-called new math, specifically the Eureka curriculum, and show you that it's not nearly as scary as it looks. Seriously, right? You see all these charts and weird instructions for what seems like a simple multiplication problem, and it's just baffling. It can really feel like the fundamental rules of math have been completely rewritten. But trust me, you're not alone in feeling this way, and we are going to crack the code today. You know, the biggest difference really just boils down to one thing. Most of us, we learned a bunch of shortcuts, these little tricks to get the right answer. This new way, it's all about building a real, deep understanding of what is actually happening with the numbers. So let's get right to the heart of it. We're going to look at the one core idea that once you really see it, makes this whole new math thing finally click. This is it. This is the golden rule. If you take away only one thing from this, let it be this right here. The decimal point is an anchor. It doesn't move, ever. It's the numbers that do all the moving, shifting left and right. And that simple, powerful idea, well, it changes everything. And that whole anchor rule is part of a bigger philosophy they call a story of units. The idea is that math should tell one consistent story. I mean, think about it. Knowing that 10 ones make a 10 should feel exactly the same as knowing that 10 tenths make one whole. The rules shouldn't just change because a little dot shows up. Okay, so what does this shifting actually look like? Well, it all comes down to using one really simple but incredibly powerful tool. Enter the place value chart. Now, I want you to forget seeing this as just a static set of labels. Instead, think of it as a dynamic workspace, kind of like a board game where the numbers can literally slide back and forth. All right, let's try it out. Let's take the number 4.215 and multiply it by 10. Now, when we multiply by 10, each digit becomes 10 times more valuable, right? So, to show that, we just slide every single digit one spot to the left. The 4 that was in the ones place, boom, it's now 4 tens. The 2 in the tenths place, it's now 2 ones. And you see the result? 42.5. There's no magic, no mysterious moving decimal point, just a clear, logical shift in value. And guess what? It works the exact same way for division. Let's take 421 and divide it by 100. Well, 100 is just 10 times 10, so we need to make the number 100 times smaller. That means we shift every digit 2 places to the right. The 4 in the hundreds place slides over to the ones place, and just like that, we get our new number, 4.21. It's the same visual, consistent process every time. Okay, so now we have this one powerful rule, this digit shifting thing. But here's where it gets really, really cool. This exact same simple mechanic unlocks concepts that seem way more complicated, like exponents and even the metric system. So first, a super quick refresher on exponents. They're just a kind of shorthand, that's all. When we're talking about powers of 10, the little exponent number is just telling you how many times to multiply by 10. So 10 to the power of 3 doesn't mean 10 times 3, right? It means 10 times 10 times 10, which gets us to 1,000. Now watch how this makes a problem that looks scary actually pretty simple. 6.4 divided by 10 squared. All we do is follow our rule. The operation is division, so we know we're shifting to the right. The exponent is a 2, so that tells us how many places to shift. 2 places it is! The 6 and the 4 both slide 2 spots to the right, and there's our answer, 0.064. The exponent is basically just the instruction manual for our shift. And this is why the metric system is so brilliant. It's literally built on the exact same base 10 logic we've been talking about. Every single unit, a kilometer, a centimeter, is just a power of 10 away from the meter. It's basically a giant place value chart for the real world. So converting between units becomes the exact same process we already know. To turn 13 centimeters into meters, you just think, okay, I need to divide by 100. What does that mean? It just means shifting our digits 2 places to the right. So 13 becomes 1.3, then 0.13. Done. Same mole, just a different application. So you might be thinking, okay, I get it, but why? Why go through all this trouble instead of just using the old tricks? Well, the answer is all about building a foundation that's actually going to last. Let's just take that old add a zero trick for multiplying by 10. Sure, it works fine with whole numbers, but the second a decimal shows up, the trick completely falls apart. 5.5 times 10 is not 5.50. That's the same value. The shortcut hits a dead end and just creates confusion. But our shifting digits rule, it's universal. It works every time. 5.5 shifts to 55. It's reliable. The curriculum actually uses examples of common mistakes to show why understanding the concept is so important. Look at Tia's mistake here. She thought 10 to the fourth power was 40,000. She got confused and thought the 4 was a factor, instead of understanding that its job is just to count the factors. That's a huge misunderstanding that a simple trick can't ever fix. Or take Jasmine's error. She multiplied 700ths by 1,000 and got 7,000, but she forgot where her number started. Her starting point wasn't 7, it was 0.07. If you correctly shift those digits 3 places to the left, you get 70. Knowing your starting unit is the difference between getting the right answer and being off by a massive amount. Look, at the end of the day, this method isn't designed to make math harder, it's designed to make a kid's understanding of math stronger. It builds this resilient, flexible understanding of our number system that isn't going to crumble the second they hit algebra or chemistry or physics, any field where you really have to know how numbers work. And that really leaves us with one final thought. By focusing on a single, consistent rule that explains the why behind it all, you have to wonder, is this really some crazy new math? Or is it just the first time that math is being taught in a way that truly and finally makes sense?